All right, this is the Math Models Unit 9, Lesson 9 video for examples of variation in science formulas. So this whole lesson is looking at some famous laws in physics, especially that apply the ideas that you learned in the last two lessons. So I've put all the formulas on the formula sheet that I shared with you. And they are starting here: Hooke's law, Newton's law of motion, Boyle's law. There are others in the lesson, but not all of them are actually used in the questions. So I only put the ones that you really needed, the ones that are relevant. So let's scroll down and look at the first questions. So the first three, maybe four questions deal with this spring idea. And it deals with Hooke's law. Hooke's law tells how much the force is being applied on a spring, depending on how long it's been extended, how much force there is pulling it, in a sense. It says how much a spring with a spring constant of 380 Newton meters, Newton per meters, I guess is that what it is, has a force of 37 newtons applied to it, stretching it. How much does the spring stretch? So in this formula, we have F, which is the force, we have K, which is the constant, and we have X, which is the extension length. So we have, in our problem, we have the spring constant, which is our K, and then we have our force. And so we are looking for the X. We are looking for how much it's being extended. So then we need to do, if we're solving for X, we are going to be doing F divided by negative K. So I'm just helping you understand. You would need to plug in the F and the K and then solve for X. So that means we divide by K. So in short way of saying is we're going to do F divided by K to get X. So we're going to do 37 divided by 380. 37 divided by 380. So let's go here, 37 divided by 380. And we get 0.009. So let's jump over here. Or 0.09, so 0.097. Oh, there it is right there. So negative 0.097. I forgot to put the negative. If I would have, our answer would have been negative, obviously. So that's my mistake on there. But that's pretty much all you're doing. You're just putting it in the right place in the formula. And you're going to do it for all of these. So a force of 50 newtons will compress a spring to 2.5 meters. So you have your F and you have your X now. So you solve for K. So always just rearrange the formula so that you're solving for the thing that you're looking for. In this case, we're looking for K. The rest of these are pretty much all going to be like this. You have your K value and your X. So you multiply them. You have your F and you have your X. So you solve for K. Looking down at number 5, this is going to be a different formula. This is going to be the Newton's law of motion, which is force equals mass times acceleration. And you're just going to be plugging things in. Again, it's very similar. I don't even think I'm going to do an example of this because it's so much like the one we just got done doing. You have the mass and you have the acceleration. And you multiply them because force equals mass times acceleration. So you do 1,500 times 6. And you get 9,000. So that would be the value of the force. And each one of them is going to be the same idea, but things are going to be in different spots. So you have a block has a mass of 12, so that's mass, and a force of 155 newtons. So that's the force and the mass. So then you would need to rearrange and solve for the acceleration. So you divide by m, so you do force divided by mass. But in all cases, you're just either dividing or multiplying to get the answer. Same thing on 7. Same thing on, now 8 deals with the new law, which is Boyle's law. Boyle's law is the pressure of the beginning and the volume is equal to the pressure at the end and the volume at the end. So you have here, it's like weather balloon has a volume of 2 liters and pressure of 1.5. We'll have what volume when the pressure is 0.8? So let's do this one together. So we know that we have pressure times volume. So we have pressure times volume. We have 1.5 times 2. And that's on one side. And then after the pressure is 0.8, parentheses around that, 0.8 times, we don't know. What's the volume? We'll call it V2. So then we need to do 1.5 times 2, which is 3. So that's what goes here, 3, equals 0.8 times volume. So we divide by this 0.8, divide by 0.8 on both sides of the equation. And that's going to give me the volume. So 3 divided by 0.8, 3.75. Let's see if that's there. And there it is, 3.75. And then this last problem is another Boyle's law. Again, multiply the pressure and volume at the beginning, and it equals the multiplication of the pressure and the volume at the end. And that's going to be number 10 as well. So that gets us 3. So you have your 3 formulas. You're plugging everything in and then solving for the thing that you're missing. And that's pretty much all you got to do in these.